Okay, so this is a 3x3 system, 3 equations, 3 unknowns, and we are going to solve it by substitution. You can also use elimination, but this video is all about substitution. And so your first step when solving these is I like to number the equations 1, 2, 3, just so I can refer to them and stay organized. And so your first step is to pick an equation and then pick a variable to solve for. Look for variables that have a 1 in front of it. It's easiest to solve for those. And so I'm going to pick equation 1, and I'm going to pick the variable x because I'm not going to have a number to divide by. All I have to do is move these other terms to the other side. And so my new first equation would be x equals positive 6y plus 2z. Just switching those signs, and then the minus 8. Okay, and so you're going to use that new equation to substitute the x in the other two equations. And so my new equation 2 would have negative, and then put a big set of parentheses where x used to be, and then go ahead and finish writing the equation first. And then you're going to do the exact same thing with equation 3. I'm going to run out of room. Okay, and so then you're going to fill in the x with the new expression. So I know x is equal to this. So we're going to substitute that expression, 6y plus 2z minus 8, into both equations. Right? And so now we're going to simplify all of these. All we've done so far is substitute the x using our first equation. And so you're going to clean both of these up as much as you can and keep them in standard form. That's going to be the easiest. And so for this side, we need to distribute a negative 1, the invisible 1, and that becomes negative 6y minus 2z plus 8. Copying down the rest of the equation. And then we're going to combine our like terms. And so I've got a negative 6y and a positive 5y for negative 1y. And then negative 2z plus 3z is positive 1z. And then I like to go ahead and move my constant to the other side. And so my constant is positive 8, so I'm just going to subtract 8 from the other side. And so that becomes negative 6. Okay, and so this is what I call equation 4. We're going to use that in a bit. We need to clean up this equation for what I call equation 5. And so same thing, we have to distribute the 3. So I get 18y plus 6z minus 24 minus 2y minus 4z equals 18. Combining our like terms, I have 18y minus 2y for 16y. And then I have 6z minus 4z to give me 2z. And then I'm going to move the constant to the other side. 18 plus 24 is 42. Now, this is our equation 5, but before I commit to this equation, if you see a GCF, a number that you can divide all of these by, you're allowed to do that. And without a calculator, it's going to be nice if we keep these numbers nice and small. And so all of these 3 places can be divided by a 2. You're allowed to multiply, you're allowed to divide, as long as you do it to every term. And so my new equation would be 8y plus 1z equals 21. So that just looks a lot nicer to use. Okay, and so that's going to be my equation 5. And so you take equation 4 and 5, and that gives you a 2x2 system. So negative 1y plus 1z, and then I might just get rid of these ones to make it look simpler, equals negative 6, and then 8y plus z equals 21. Okay, so this is set up really nicely for elimination. If you wanted to solve this by elimination, it doesn't really matter which way you solve your 2x2 system. That's an Algebra 1 concept. And so if you wanted to use elimination at this point, you could. This is equation 4, this is equation 5. And so to use elimination, I would multiply the entire top equation by a negative 1. And that would give me positive y minus z equals positive 6. And so when I add these together, I get 9y. Z's cancel, eliminated, equals 27. Divide by 9, you get y equals 3. Okay, and so once you have the y value, pick any of these equations to solve for the z value. And so I'm going to pick this top equation, negative y plus z equals negative 6. And so now we know y is 3. And so negative 3 plus z equals negative 6. Add your 3. So z equals negative 3. Okay, and so after you solve this 2x2 system, you now have your y and your z. And so you take your y and z and go all the way back to this first step where we already solved it for x. And then we can substitute the y and the z values to solve for the x. And so I know y is 3. And I know z is negative 3. And so we just simplify this. We get 18 negative 6 minus 8, which gives us 10 minus 6, which is 4. And so our x value is 4, our y value is 3, our z value is negative 3. We write our solution as an ordered triple. Instead of an ordered pair, it's an ordered triple. Your x goes first, then your y, then your z. And so your x value is 4, your y value is 3, and your z value is negative 3. So in the XYZ plane, this is the point of intersection of these 3 lines.